Hey, in this video, we're going to learn about the difference between relations and functions in math. And according to dictionary.com, the non-math meanings of relation are shown here. So a relation is a connection or an association between or among things. For instance, your relations would be your family because there's a connection between you and your family. Okay, in mathematics, it's a property that associates two quantities in a definite order. So, for instance, an XY ordered pair, right? The order matters. So it's similar to the math definition. It's a connection or an association, but in mathematics, the order matters. Okay, so on the front of the notes, here's our definition for a relation. It's a pairing of input values, and those input values we usually call x in the equation, and that is our domain. We'll be talking about domain of a relation in the next notes. We're going to pair those x values, those input values, with the output or the y values. Okay, and the output we call the range. So the x is going to be our domain, the y values would be our range. We pair those x, y values such that the order matters. So in an ordered pair, x comma y, right, that's how we write the coordinates of an ordered pair on a graph, right? That order matters. The point 1 comma 2 is located at a different place on the graph than the point 2 comma 1. Okay, that's what we mean by the order matters. And we also see relations not just as a set of ordered pairs, but an equation with two variables. For instance, y equals 2x plus 3. Right, that relates the x and the y. If I input a number for x, such as 1, right, 2 times 1 plus 3 is 5. So when x is 1, that's the input. The y, the output, is 5. Okay, that's what we mean by a relation being an equation with two variables. Okay, a function is a special type of relation. So if your relation is one where each x value pairs with one and only one y value, that's a special type of relation called a function. And we'll look at some examples of functions in the coming pages. Okay, so a relation can be represented as an equation or in these four different ways. The first way we'll see the relation is as a set of ordered pairs. And ordered pairs in a set will begin and end with these curly braces, right? Those curly braces are called set builder notation. And what's inside of that set, inside of those curly braces, we have elements, 1, 2, 3, 4, 5 elements separated by commas. So the element -2, 3, that ordered pair, is separate from the one that follows, 2 comma 0. Okay, so our ordered pairs, we've got 5 of them. The x, the input, is -2. The y value, the output, is 3 in that first ordered pair. So if I was going to graph it, I would come over here to -2 on the x axis and then up 3 in the y direction, and that would be the ordered pair -2 comma 3 on my graph. And if I plot the point 2 comma 0, I come over 2 to the right in the x direction. The y is 0, so I don't move up or down, and there's my point. Okay, -2 comma 0. Now I'm going to go 2 to the left in the x direction. Again, my y is 0, so I'm not moving up or down. 1 comma 3 is going to be 1 to the right and up 3. And then 1 comma 0, I go 1 to the right and remain on the x-axis. So this graph is called a scatter plot, right? We've got points that represent these coordinates, the ordered pairs in my set. Now they're plotted on a graph. So we can represent that same data that we had as a set of ordered pairs now on a graph. Okay, an XY table you've probably seen before in Algebra 1. That's another way to represent these points, these ordered pairs, and we just list all the X's and the Y's that go with them, but we're doing it vertically in a table instead of horizontally in a set. So the X, when it's -2, the Y value is 3. Right? When the X is 2, the Y value is 0, -2, 0, 1, 3, and 1, 0. Okay, there's nothing wrong with how we have it represented here, but typically we would see in an XY table the X's listed in least to greatest order. So I'm going to go ahead and redo this table in that way. Okay, again, there's nothing wrong with having them mixed up, but just typically you're going to see your -2's listed first, then we'd have the 1's, and then the +2. So our X's are going in order from least to greatest. The -2 has a Y value of 3, and it has a Y value of 0. Right? Again, I would probably want to put those from least to greatest, so I'm going to go ahead and switch. So this is going to be -2, 0, and -2, 3. Okay, then I've got my 1's, 1, 0, and 1, 3. And then my +2 has a Y value of 0. Okay, so we can see our X's going from least to greatest and the corresponding Y's. Now, in a mapping diagram, the first oval, that would be your inputs, your X values. The second oval, those are your outputs or your Y values. So the X is the domain, the inputs, the Y is the range, the outputs. In a mapping diagram, you're going to list the elements that are in the domain, the X values, from least to greatest, like we did in the table, but with no repeats. So since this -2 is repeated in the table, we only list it once in the mapping diagram, right? The 1 is repeated in the table, but we only list it once in the mapping diagram. Okay, so -2, 1, and 2 are the X values. The Y values we can see in the table are just 0 and 3. So again, we're going to list them one time each from least to greatest in the oval. And we use arrows to show the relationship between those elements. So we can see from our table, -2 points or maps to 0. So I draw an arrow from the -2 to the 0. But -2 is also associated with the 3. So I have another arrow coming from the -2 in the domain to the 3 in the range. Okay, 1 is associated with both 0 and with 3. Okay, then the 2 is only associated with 0. So the arrows show the association or the mapping from the elements in the domain to the elements in the range. And that one is probably the least intuitive. You've seen sets of ordered pairs tables and scatter plots in Algebra 1. Mapping diagrams might be new to you. So go ahead and pause the video, and I want you to try to take this mapping diagram and change the form, the representation of that data into a scatter plot, a table, and a set of ordered pairs. And then when you're ready to check, you can resume the video and see how you did. Okay, so this -1 is mapping to -1, so that would be a point on my XY table, -1, -1. The 0 has an arrow pointing to -2, so 0 maps to -2. 1 maps to -2 as well, following that arrow. And the 2 has 2 associations. The 2 maps to 1, and the 2 maps to 3, right? I have 2 arrows coming out of that element of the domain. Okay, when I want to put those ordered pairs into set notation, I'm going to start with a curly brace, and then my first ordered pair, -1, -1, then a comma, and my next ordered pair, 0, -2, a comma, then I have 1, -2, 2, 1, comma, and a 2, 3. And then I close that set with a squiggly brace. Okay, on my scatter plot, I'm going to plot these points. So -1, -1, 0, -2, +1, -2, +2, +1, and then +2 and +3. So there's my scatter plot. Okay, go ahead again and pause the video. Try this one. Take the mapping diagram that's shown and just plot it as a scatter plot. And when you're ready to check, you can resume the video. So here is the answer, right? -3, -1. Then -1, -2 is right here. Okay, +1, -1, 2, 0, and 2, 3.